Maybe soon. Audio's on? Yep. Oh, perfect. Thank you so much for being here. Have you looked at the watch? Do you know what time it is? It's the last session of the day. Why are you still here? No, but I'm so happy to see at least some faces, because I know it's been a long day. There's so many awesome sessions. And yeah, the last sessions tend to kind of get dropped by the wayside because there is a good spa at the hotel. Just saying. So a couple of things. First, it scared me because I had not put SQL bits and Dell Technologies on my slide, and suddenly it was there. So yeah. This is the spell of transmutation. How many of you have ever played role-playing games? All right, we have an issue in this room, but that's okay. We can work with that. So transmutating something, it's not necessarily anything to do with role-playing games. It's the art of taking one element, such as iron, and turning it into another element. You can do that if you're a star or a nuclear furnace. And if you're either, you shouldn't be in here. But we're going to do pretty much the same thing with Azure and SQL. So again, transmutation is the fictional idea of turning one element into one other, right? Moving data around can sometimes feel like this. It's 50% magic, 50% frustration, and another 15% or so of actually getting it to work. Where the laws of physics are just about unbendable, in reality, you can bend a lot of rules in Azure. And there are so many cool things in Azure that we can look at in a bit to get your data from A to B and doing magic things with it. There's about 1,000 ways you can do it, and this is going to be how to do it with Debezium. We're going to look at why near real-time data transfer might be a good idea, why it might be a terrible idea. And if any of you were in my last session, we talked a lot about definitions. What does near real-time really mean? Because that's kind of critical. We're also going to look at what it is, what is Debezium, kind of a cool name, isn't it? And how can it actually be used in the first place? And finally, how do we get the darn thing up and running? Here's a top tip. It's not that easy. Ask me how I know. And I'm going to show you just where I fell over a few times. The goal today is to give you an overview of Debezium and some ideas of what opportunities it might bring. I am not going to give you a complete step-by-step, do this, do this, do this, because we only have 50 minutes. I do have a couple of demos that I'm going to show you, and I'm a fan of not doing live demos because they tend to fall over, which they did, so I've recorded them, and there's a good reason for that. My name is Alexander. I am not an American. I'm a Swede, but I'm not going to do my Swedish accent for you because everybody's going to up and leave. I have roughly 25 years in IT. I put my fingers in just about every pie there is. But about a decade ago or so, I decided that, oh, wait a second, tech is cool. People are where it's happening. So at the end of the day, I try to take data and do things with data in order to create outcomes. I am a principal solutions architect, and if anybody knows what that is, let me know, because I don't. But what I can say is I try to make data matter. I co-host a podcast called Native in Tech. I'm one of 9, I think, data platform MVPs in Sweden these days. And for the people in the audience in my age or older, yes, that is the Doom game logo. And Doom is the best game ever. Anyone opposed? Good. Just setting it out there. So let's start with why would you even bother with Debezium? Well, it's not so much why would you bother with Debezium. Why would you bother with real-time transfer at all? The reason why I created this session was that a customer came and said, we want to have a data source, in that case, SQL Server, and we want to have that data decoupled from SQL into Azure, dropping it into Event Hub. and we want to have that in real time. In real time, that is one of the most dangerous words that you can hear. The most dangerous word, you know what that is? Excel. But we're not going to talk about Excel today. No. But near real time or real time, that is setting off all bells and whistles in your head, because that means it's going to be difficult, it's going to be expensive, and it is going to be complicated. Maybe that's what you want, that's fine, but be careful with that concept. Debezium lets you do near real time, as in I insert a row in a SQL or any kind of data source that Debezium can handle, and it grabs that row and tosses it somewhere where you can use it downstream. And that means we are decoupling the data source from the, well, essentially where we want to put it. So I'm going to show you what it is and how that works. So now we know why you want to do that. Say, for instance, that you have a system, and this can be on-prem. It doesn't have to be in the cloud. It can be any data source that you have a connection to with Debezium. Say that it's on-prem. It's an old system that just keeps ticking. HR system or production system, whatever. And you want to grab data from there, but you are not able to hack into any APIs or stuff like that. But you do have control over the database. Then you can take all the changes in the database, grab them just smoothly, and walk away with them and do whatever you want with it. You're essentially grabbing data out of a legacy system and doing what you want with it. Kind of cool. Yeah, but what are all these thingamajigs? There is a few of them, I'll say that. We're going to start with a data source. It would kind of be boring without a data source. The data source needs to support CDC or any kind of change tracking. The source needs to be able to handle, essentially scream at, yeah, we have a new row here. And exactly how this mechanism is implemented, it depends on the data source that we want to connect to. SQL Server behaves in a specific way, and SQL Server is using, Debezium on SQL Server is using CDC, or change data capture. We can do this with a lot of different data sources. We don't necessarily need to use SQL, and while we're on the topic of SQL, it doesn't need to be Azure SQL. It can be SQL on-prem. It can be a pretty old SQL, actually. I can't remember from the top of my head when CDC came out. It was either 2000 or 2005, but it was quite some time ago. Who of you were in the BI Power Hour, by the way? Yeah, a few. They showed the latest SQL Server, was actually SQL Server 2000. And a lot of people didn't even know what they were looking at, so that's kind of fun. But we can bring stuff from MySQL, from Cosmos DB, from managed instance. It doesn't really matter. As long as there is A mechanism for handling changes, and B, a connector in Debezium, you're good to go. Then we have a container instance. This is the secret sauce, if you will. It is a container instance that runs Debezium. Debezium is the software that takes care of all these things for you. This one extracts the changed records. It does some things to it, depending on how you've configured the whole thing, and then it just boots it downstream. You can boot it into just about anything you can think of. I am going to toss it into Event Hub, because Event Hub is in turn going to give me a number of interesting features. Speaking of Event Hub, what is the Event Hub? Well, the Event Hub is a mechanism for, again, decoupling messages. So we're taking a database, in this case, which is as far away from message-based as you can come, and essentially going through the hoops to be able to treat it as a message-based, like a microservices-based data transfer. So as it says, it decouples the store stream from the outputs. It no longer has any connection to your data source. It's going to live its own life, and you can do essentially with it what you want. You're taking control of the changed data, and yes, if you really want to and you really have to, you could use this mechanism to migrate stuff over time, for instance. All right. Stream Analytics. Stream Analytics is a serverless event processing engine. It is also an expensive processing engine. Just putting that out there. This one is awesome. It's a low-code, somewhat no-code way of processing messages. Be careful with it. I love it, but it does come with a few caveats. We're going to look at that slightly later. So, what do we have? We have a data source. Awesome. We are using a container to grab the change records. The database goes, this one is changed. Debezium goes, I'll take that one, thank you very much, and brings it to Event Hub. It posts it as a Kafka-based message. I'm going to come back to Kafka in a bit. From here, the world's your oyster. You can do essentially what you want with this message. You can toss it into Stream Analytics if you want to. You can toss it into an Azure function if you want to. You can dump it into Synapse if you want to. And why choose? You can do all of these things at the same time. It doesn't really matter, because as soon as Debezium has tossed it into Event Hub, it has nothing to do with the SQL Server anymore. The data source is completely decoupled, and what you do with the messages, the data downstream, does not impact the source. Everybody with me so far? Cool beans. Right. How can I play with it? That's a great question, and I'm so glad you asked it. Now, here is where the story becomes fun, depending on how you define the word fun. So, client goes, I want to have near real-time data transfer into Event Hub and Azure. There are a couple of ways we can do that. We could have run the SQL Server 22, what is it called? The something link, Synapse link for SQL Server 2022. That would be awesome. We were not running SQL Server 2022. Okay, toss that idea. We could run Azure Data Factory. No. Buy everything that is holy. Do not try to use Azure Data Factory for anything that is close to near real time. Why? Ask your wallet. Anybody has ever seen Star Wars in here? A few hands. Remember the trash can-sized droid when it does this screaming sound? That's the sound of your wallet if you try to run Azure Data Factory on a near real-time basis. Don't even try. So what I found was Debezium. It's an open source project. It's there for anyone to play with, and there is an amazing example on GitHub. And anybody who's in the consulting space knows, how do you learn something? Well, you steal it. You go to GitHub and you look at the code and you look at the examples, and yeah, I mean, there's an example. Thing is, this one is a bit old. And it has a few issues. Again, ask me how I know. So I'm going to show you a few things, a few gotchas, so hopefully you don't need to step into the same mess that I did. A bit of a background for you. I come from the database world. I cannot code if my life depended on it. I can do SQL just fine. C#, no. PowerShell, my colleagues laugh at me, just so you know where I'm at. The idea of low code speaks to me. So I took this and I started playing with it. Now there's one thing that I am more scared of than coding. It also starts with a C, but it's called containers. I think containers are evil and they hate me. But yeah, who cares? Let's try this. So you can go on GitHub and grab that example, and then you just play with it. What do you need to get this up and running? There are a number of prerequisites. You need to have a resource group. Duh. Anybody who's ever been in Azure, well, you need to have a resource group to put your stuff into, but just make sure that everybody's on the same page. You need to have something, in this case, an Azure SQL Server. It could just as well be an on-prem server if you wanted to. But I'm going to use an Azure SQL Server because the whole thing is contained in Azure. I know where it is, I know what it's going to cost me, and I can shut it down when I'm done. You may or may not need a storage account. This depends slightly on how you want to consume the change feed. I'm going to come back to that in a second. Warning number one, gotcha number one. SQL Server has a firewall. Nope, actually SQL Server has two firewalls. Yeah, ask me how I know. Now, so the first thing you need to do is to open the firewall to other stuff in Azure. Otherwise, you're going to bang your head against the wall for quite some time before you figure that out. Luckily, that's my wheelhouse, so I didn't mess that thing up. I'm going to mess a lot of other things up in a bit. So let's start by preparing the SQL Server. Remember, I'm Swedish, so like a Swedish chef, I have some things prepared for me. We're going to start by creating a user. For the most part, your source system is already up and running. But this is just to create the demo environment for us to play with, right? So started with, oh, that's interesting. Starting with creating a user. Create user and alter role, because we need to add that member to the role DB owner. Now, look at the documentation. -- green text. Make sure that you connect to the right database. Otherwise, you are going to create this user in the wrong place. So just a bit of a sanity check. With the user in place, what do we need then? We need to turn on CDC, Change Data Capture. This is exceedingly complicated. One of the most difficult things you can do in an Azure SQL Server. Yeah, that's how you turn it on. Not hard. With CDC turned on, it's time to decide what tables to look at. So let's create a table. Let's call that Transmute. A varchar and B varchar. Never ever do this in production. Of course, I don't want to get sued. With that, let's enable CDC on the tables. SP CDC enable, specify the table, if you need a role, support changes, all those things. This is all part of the example. And I'm going to be putting my demo scripts online as well when this is done. With that, we're ready to go. But there are a couple of gotchas. As I said, ensure that the user is created in the right database. Yeah. And ensure that the database is running before you take the next step, which is setting up the container. This one is a bit insidious, because one of the challenges you're going to find with Debezium is that the error messages are not great. Not only are the error messages difficult to read, they can also sometimes be difficult to find in the first place. So save yourselves a lot of trouble. Again, ask me how I know. Make sure that the SQL database, your source, is up and running before you start to add Debezium. This also goes if you want to put this into production. If you need to restart Debezium for some reason, make sure that your source system is up and running first. All right, good stuff. So how do we actually set up Debezium? Now it's going to be somewhat more interesting. We need to start with an Event Hub namespace. We can do this in a number of ways. We can do it through PowerShell. We can do it through ARM. We can do it through Bicep, which makes Haney very, very happy. Or you can do it, well, any way you want, including the portal. And creating the Event Hub namespace, depending on how you do this, some parts are going to be automatic, some are not. So how do we do this? Well, let's go into the portal, create a new resource. It's slightly small. I'm going to zoom in just a second. I'm saying, give me an Event Hub. We're going for it. And then we specify a number of settings. Let's see if I can do this. Did that actually work? No. Zoom it does not really like a presentation mode. What I'm saying here is we are specifying a name for the Event Hub namespace. I am putting it in my local area, which is Western Europe or Sweden. I usually put my stuff in Western Europe. And then there are a few settings below that essentially controls how many units do you want to have. The lower one is essentially how much power do you want to give this. That's it. That's all you have to do. Now, if you do this through PowerShell, it's not going to give you something called the Kafka endpoint automatically. If you do it through the portal, it is. Again, ask me how I know. Because if you don't have the Kafka endpoint, it's going to break in a bit. But we're doing it through the portal, so that's all fine and well. Next step, well, it's not so much that we need to do on the advanced side. Don't touch, really. And then we go for networking. It's the same thing there. We're not going to touch this. You could potentially start to fiddle around with private networks and stuff if you really want to communicate things. For the demo, not at all. Nothing like that. Just next, finish. You know, as you do when you're setting up SQL Server. Nobody reacted to that. Everybody just goes next, finish in SQL Server. Oh boy, we need to have another discussion. Right, that done. Skip the tags. And I think we're just about ready to go. So let's press play on tape. And it takes a minute or two to set up. And what you've created now is a namespace. Look at that as an umbrella where you can put in Event Hub stuff in. So this is the container, but it's not a container per se. I hate the wording. But that's where you put everything that has to do with Event Hub. Cool. And if we were to go to the resource, this is what it looks like. It's essentially empty, but you have a number of settings, and you can see if there is anything going on. I don't have any Event Hub defined yet. I have an Event Hub namespace. Again, the kind of overarching thing where you put Event Hubs, but I don't have an Event Hub in here yet. Here is where I don't recommend you to keep going with a graphical user interface. You could just click create a new one and put in all the stuff. You could do that, but it's probably better to use ARM or PowerShell or something like that, because you're going to need to put in a lot of different things. More about that in a sec. Gotchas. Remember what I told you about Kafka? Oh yeah. If you do this through PowerShell, which I do in my demo scripts, be very sure to put in that you want Kafka, enable Kafka equals true. Because otherwise, you're not going to get a Kafka endpoint, and that is going to make things difficult for you. If you just do it through the portal, the Kafka endpoint is going to be well awake and happy, so everybody's happy. Okay. So we have the Event Hub. It's time to create the container. Containers are very much akin to black magic. At least if you ask me, because I cannot seem to get my head around them. But again, there are scripts for that I could steal and slightly tweak. So whipping up a fairly quick script to create a container is essentially creating the container and then bringing some kind of image in from the internet, in this case, you can have it locally, to whip up and start Debezium. The good thing here is Debezium, they take care of packaging the whole thing. You don't need to create your own container. You can do that. If you're into containers, that's fine. I don't judge. I'm not. So I'm not going to try to do that. I'm just grabbing the one that's already there. Having done that, it's time to configure the whole thing. There's a lot of text. I know that. We're not going to go into it in detail, but again, I'm going to have a blog post up explaining all these things. Most of this was part of the original example that I pulled from GitHub. I say most of it because, as you can see up to the right, there are a number of things that are most important. Debezium is 2.2, I think. It could be 2.2 or 2.3. They've done some pretty substantial changes going up north of 2. So I stuck with 1.9. The original example is for 1.7, but the difference between 1.7 and 1.9 is not really much. And for the sake of this demo, there's no difference between them. As you can see, connection string, that is the endpoint that we're referring to get to the service bus. And the service bus in this case is Event Hub. So this is where we connect all the things. We feed this into the container, or into the creation of the container, and push play on tape. And it takes a while because it needs to go and grab this from the internet, but it's surprisingly quick anyways. It starts it does some running. It's fairly quiet in the beginning. As long as it doesn't stop and scream at you, you're going to be good. This is where we should have some button to do elevator music. It's running. It's still running. And that's pretty much it. You're not going to see much more than that. With it up and running, now comes the interesting part. Because, oops, come back. So AZ container show in this case just shows me where is the container, what kind of settings do we have, and yeah, we're good to go. And I apologize for the font size fly spec. Zoom it does not work for this specific thing. With the container up and running, so far we have not needed to really think about settings. So far you could have followed along the original example and would have been fantastic. And this is where it breaks. If you try to use the original example that's on GitHub. Because there's a lot of settings that you need to configure. And then you need to take these settings and shoot them into the container. So the container is up and running, it's not configured, but now it's time to actually configure it. We're doing that through a REST API call to the Kafka endpoint. So I'm just using invoke command in this case, and shooting that into the container. There's a lot of things that you might recognize here. This is where we specify, for instance, the database password. Debezium needs to know how to log into the data source. We also, and this is a big gotcha, have something called $connection string. Anybody who's ever done essentially anything in Unix or any programming, this is clearly a variable, right? Yeah. This is a variable in a variable. It's a huge inception thing. Because you have the configuration where some things are going to be turned into the actual file names or connection strings, but you still need to have $connection string. It's supposed to be that way. It took me the longest time to figure out that no, this is not supposed to be turned into something. It needs to be $connection string. Took me some while. With that, all right, let's invoke post method or REST method in PowerShell and shoot this into Debezium and see what's going to happen. It's going to say a few things. It's going to come back with a configuration. Here's a top tip if you're ever speaking. Be very careful where the edge of the days is. I've fallen off one of those things once. I don't recommend that. This is where we get a config. It's called deb in this case because I specified it to be deb. All the way up, we have a connector to SQL Server, and we have a database hostname that points to SQL Transmute, which is the name of my database. This is just to make sure that we have a connector. That's something that I created in the step before, because if I don't have a connector, that means that I had something wrong in my connection string or in my JSON code. But with that, everybody's happy. With that, I can keep going into the next step. What I'm trying to do here is looking at what's the state of this connector. This one is important. This one is really, really important. Because it's going to start up, it's going to take some time, then it's going to try to do its thing, and either it's going to run happily or it's going to fall over. Depending on how you set things up, previously I'm going to show you where you might mess things up. It's going to work fine until the first data, the first row of data comes in. Then it's going to fall over. So there are a couple of gotchas. First, there's something called snapshot mode. And you really, really need to know what snapshot mode does. Schema only, which again is the original example, means that it's not going to take any data that's already in the data in the table when you start up Debezium. So this means essentially that when you start up Debezium, it's going to put its ear to the ground and expect changes. If you don't do a schema only, you go for initial, I think it's called, then it's going to grab all the data. That may or may not be what you want. So just be aware of that. Another gotcha. If you come up with a great idea to run a SQL Server as a serverless SQL Server. Serverless is awesome because it's going to go to bed and not cost you a cent when it's not being used. Here's a pop quiz for you. What do you think the container is going to do as soon as it starts up? What does Debezium do? Well, it's essentially going to behave like your annoying little brother. What are you doing? What are you doing? What are you doing? What are you doing? Every second like crazy, meaning your SQL Server is never going to go to bed. So the great idea that I could save a lot of money using serverless, yeah, bye-bye. Just be aware that as soon as you kick off this Debezium container, it is going to hammer the database continuously. Another thing that you need to think about is the include list, and that's fairly obvious. What tables do you want Debezium to listen to or listen for? In this case, dbo.transmute. You can do a few things if you want to just grab all the tables in the database. I'm going to come to that in a second. Decimal handling mode. How do you want to handle different kinds of data types? I think you might want to look at this one. I went with string because that means that I can take care of that downstream. There are some pretty funky behaviors if you don't go for string. If you want to keep things numerical, you can definitely do that, but you never really know what's going to come downstream. So I went with string, and that worked for my specific use case. So remember what I told you about the whole dbo.transmute and include list? Yeah, this is how you put in a regex to let Debezium choose what tables to use. This might be a better choice if you have a big number of tables that you want Debezium to grab on. Otherwise, you need to specify them one at a time, really. And finally, tombstones. This is a behavior with Kafka. If you delete something, not only is it going to turn into a delete statement, it's also going to add a tombstone, which is a part of how the Kafka protocol works. You don't want tombstones in this because it's going to give you even more events that in turn get tossed into Event Hub. So I turned that off with tombstones on, delete, false. All right? And finally, these are a few things that are going to bite you in the posterior if you try to use the examples in the GitHub. Because it's in the documentation. Does anybody read the documentation? Yeah, exactly. I'm getting this and some shakes of the head. No. And that's the thing. The example is exactly that. It's an example. It is not fit for production because if you turn Debezium off and on again, it is going to lose its way. There is no handling of a snapshot or a trail, if you will. It cannot handle if Debezium goes down, the database keeps working and new rows are created, and then you start up Debezium again. What's going to happen is it's going to go, oh, the change, nah, and just fall over. So that's why you need to put in something called a history. This took me quite a while to figure out, but again, I'm going to put this in the scripts that I'll be dumping on the internets. With this, how do we verify a configuration? There is no graphical user interface. Everything the only way that I know of verifying this and talking to this is through the REST API. So I need to do some queries, essentially. And you can do that through the REST API. Again, small text. You're asking the REST API, what's the state of the endpoint? And if it's running, awesome. If it's not awesome. But this is the only way that you can find that out. And it unfortunately fails quietly. It's not going to scream at you. It just falls over, and it's up to you to find that it did. So this is where you look at that. You might have some logs as well. I'm going to come back to that in a second. The log files are inside of the portal a couple of clicks down. So this is the container. And on the left, you click containers. You have the containers running. There is a tab called logs. If you click that, you're going to get to the log for that specific container. This one is not fun to parse at all. But it can be very, very useful. If the REST API just says, well, your connector has fallen over, its state stopped, but why? That's where you find the why. So how do you consume this feed? Well, now it's starting to get interesting. So far, we've set the whole shebang up, but how do we actually use it? Well, you can do a number of things. I'm going to use an Azure function. So remember where we are. We have a data source. We're using change data capture to capture the changes. Then we have Debezium grabbing those changes, tossing it into Event Hub, and then it's time to do something with the stuff that comes into Event Hub. That's where we whipped up an Azure function. And no, I did absolutely not write this Azure function, but I stole it. And I stole it very well, I might say, because it works. So what I'm doing next is essentially running the function tools locally. You could do this and put it into an Azure function, fine. But I'm doing this locally on my own machine. That's why I'm using funcstart, the function tools, and starting the function up. Hopefully, it's going to stop here. Because it does not told me that it just fell over, which means that it's running. That's awesome. And now I can go into SQL Server, and I can add a row. Just normal inserts. Remember that SQL Server, the end users, the end software, whatever you're using, does not need to know or have any opinion on change data capture. That's just something that happens in the database. Users don't know it. They put in a row in the database, and something happens. So if I were to go there, insert a row, and hopefully, better, I get this. And what are we seeing? Well, there's a lot of text. But we can see an operation, insert. We can see when it was captured. We can see what the different columns are, the values. And we can see that it did do something with it. This confirms that we have the data in the database. We have change data capture configured. Change data capture took the changes, basically gave that to Debezium. Debezium said, oh, thank you very much, dropped the whole thing into Event Hub, and now I consumed that change stream in a function app. You with me so far? Everybody still alive? Awesome. What could be the next step? Well, we could use Stream Analytics, for instance. Stream Analytics is interesting. Don't fall for the low-code, no-code approach. Because there is a huge bug in how to set this up. So definitely set it up manually. What we have is a number of settings. We have an input, we have an output, and we have some kind of transformation code in the middle. This is just to show you that I've connected to the data lake for an output and the Event Hub as an input. With that, I'm running some kind of code. This is essentially T-SQL, sort of, kind of. It's a dialect, but it's still SQL. It's designed to do streaming data. And with that, I can see the results, and there we go. So this is how I can essentially consume this in a Stream Analytics session as well. One thing to remember with Stream Analytics is that you set it up, and then you start it. Don't forget to start it, because then it's not going to do anything. It's going to work in a test environment, but it's not going to actually do anything. So when we come back to Stream Analytics, this is hopefully what we're going to see. The lines means that there are stuff happening in Stream Analytics. And this is where you do the actual coding, right? So what we do, we select start into input and output. The job name, well, we can call it essentially anything we want. Stream, deb, that works. That's the test, creating the job, and then starting and running the job. And if you look at it, oh yeah, so this is the output. This is what I just created. I had Stream Analytics dump the whole thing into a JSON file, or in this case a CSV file, and there we go. So I have jumped through a lot of hoops to take data in a great format in a database, use just about every tool there is in Azure, and the output is a CSV. It's impressive, right? Yeah, no. But you see the potential value for what you can use, or what you can do with this. So, thank you. Debezium can enable a lot of new opportunities, because previously, getting data from something like a relational database is difficult. It's really not suited to, well, it doesn't want to share its data, I'll say that. Exporting data out of a database, you can do that, but it can be difficult. Handling anything with real-time or near real-time with a database, not so fun at all. It's not really designed for it. This is a way to decouple and grab the data. The database doesn't really know what it's doing, and Debezium is going to grab that for you. This one is not behaving the way it should be. There we go. If you want to use this, which I highly recommend you to do, test it. It has a number of quirks. It has a number of gotchas. Some days it feels like I've fallen over them all, and I've only just scratched the surface. It works great, but again, make sure you test it in a production-like environment before you even think of doing anything with it. The components that I've shown you today, they're extremely powerful. Event Hub is fantastic. I love Event Hub. Stream Analytics is a great tool to handle real-time or near real-time stream analytics stuff. But Stream Analytics can be expensive. It's not too bad to play with, but as soon as you crank it up, be careful. And remember what I told you about the container. As soon as you kick off the Debezium container, it is going to continuously talk to your database. And if that database is in Azure, well, you're paying for all the compute you're ever using. It's obvious, but you definitely want to make sure you check this out. So I promised to give you an overview of what Debezium is and essentially what it can do, and show you some of the opportunities that you can get out of it. And with the Debezium at your disposal, you suddenly find yourself with about unlimited power. Unlimited power to take data from somewhere, decouple it, and do whatever you want with it. Unlimited power to blow through your entire budget in about a day. Unlimited power to do what you want to do with the data. Use that power responsibly, as opposed to this gentleman. It's a fun thing, but be careful. My name is Alexander. I thank you so much for your time.